To keep me from coming back up again, the second presentation will be by Malena Alessandra Serrano, who's going to be giving her paper, Training in Earthquake-Resistant Construction with Adobe in the Peruvian Andes. And then.
So hello, good morning to all of you. First, I'd like to thank the opportunity to be here next to such amazing presenters. I'm really thrilled to be here. My name is Malena Serrano, and I'm a grad student at the Catholic University in Peru. I'm here to present a project we're developing next to Dr. Marcia Blondet and Álvaro Ruiñas. The project consists on the training in earthquake-resistant construction with Adobe in the Peruvian Andes. Let's begin by stating one simple truth. Humans have been building on Earth with earth all over the world for thousands of years. In our country, 35% of the population lives in adobe houses, especially in rural areas like small towns and villages in the Peruvian Andes. Adobe is cheap and accessible in most developing countries, so it's a highly used construction material for low-income families. Additionally, adobe houses have very good thermal and acoustic properties. They are really warm, kind of soundproof, and since they are cheap, they are a favorite for people. But, and here's a huge but, earthing construction and earthquakes are a perverse combination, as my thesis advisor would say. Every time there is an earthquake, thousands of people get hurt or get killed in adobe houses a year. For example, in 2007, the picture on the left up, a 7.0 earthquake in Peru destroyed or made inhabitable like 95,000 houses. Most of them were made of earth. But, here comes the second but, earthing construction can be earthquake resistant. Many studies have been made around the world, and the key word is reinforcement. Earth can be earthquake resistant, and that's something we're working on. We have done many studies. My university has done its share. We have developed many techniques, and even you can see my advisor there in the BBC being interviewed. So there is world recognized around the world. But still, people in the Peruvian Andes and small towns are living like they did 100 years ago. They are still building their houses like their grandparents did. So, now we have had a little background on the adobe problem. Now let's get into the study case. There is South America, there is Peru, my country. There is Ayacucho, a department. And that little red dot is Puyo. It's a small community in the Peruvian Andes. It's only a dot in the map, but you can see there is a whole community there. There is a church, there is a mayor, there is people, there are schools. That little town was affected because of a 6.6 earthquake last year. The earthquake was in the department of Ayacucho and damaged many communities. As you can see, those cracks are typical failures from earthquake in adobe houses. I think most of us would agree that those houses are kind of affected and nobody likes to live in them. But still, the government wasn't able to help after the earthquake. They only donated like 20 blankets. I know it's a little laughable, but that's what they did. Because there were so many other villages, there was so many people that needed help that they could only afford that. So, representatives from Puyo traveled 16 hours to the capital in Lima, and they tried to reach different organizations to ask for help. My university was one of them. So, since we have a social responsibility policy, we organized an interdisciplinary team and traveled to the zone to assess the damage and to maybe propose a work plan. We believe that interdisciplinary work is important when working with communities. We made a team of a psychologist, an anthropologist, and a historian, well, but 2 engineers too, to assess the damage in different ways, not just to see if there were cracks or how much bricks fell off the houses, but to see how people were affected, if they were scared, what were their concerns. The resulting proposal was a long-term training project. We divided it into 3 parts. The first part is supposed to awake people's interest, to introduce notions like the act of reinforcement, to introduce like the seismic risk concept, because people tend to have short seismic memory. That means that after an earthquake, everybody is going to try to reinforce their houses, but then a couple of months later, they're going to forget about it. They're going to just be like, okay, I'll move on with my life. So that way, we try to first enter their minds. The psychologist in the team has a huge part in it, to try to open their minds to ideas, that there is risk, but also there is a possibility to mitigate it. Then comes the second phase, the practical training, how to improve their housing conditions, how to reinforce their houses, what to do, what materials to buy. And finally, this is a new step we're adding, to try to follow up with the community, because prior projects have gone and said, let's do something, let's build a little house, teach people this, but then in time it's difficult to keep up, and we don't really know the statistics about how many houses or how many people are embracing the technology proposed. So we're proposing to follow up the community and get this data in order to improve methodology and maybe replicate this effort in other communities. The proposed reinforcement is the key or the base to this project. Right now, we're proposing a nylon rope mesh. Other prior reinforcement were maybe not used as much as we would have wanted it because of the difficulty to access them in rural areas, or maybe because they added a little higher cost to the building of the houses. This time, we're doing the rope mesh that it's supposed to be affordable for all low-income families and also be accessible, since you can buy it at convenience stores. There is this little video. This is just not an idea that we came up with. There have been studies. This is the structures laboratory in Lima. We have a seismic simulator, and this is a full-scale model. We did damage it first, then we repaired it with the ropes, and then we submitted, the scale and repair model with the ropes to seismic movement. In a few seconds, we're going to see it more clearly. The model shakes. It shakes a lot. But it's still the people that live in that house are going to be able to stay alive because of the rope. Yes, damage is going to get done, but life is going to be insured. And it's not going to collapse so people can repair. It has been submitted to high movement, and still it was there to stand. So that's the base of the project, the reinforcement. But now we need the tools to get in the community and try to teach this new technology how to enter them. We have developed a couple of tools. The first one consists in making a small-scale houses, and a portable shaking table is going to be used to be field demonstrated. As you can see, we built many little bricks. We built houses, and that's the portable shaking table. First, we use a non-reinforced model to prove that attic houses can be fragile in earthquakes. As you can see, that's the portable shaking table. It's kilo size. Yes, it's me, I'm sorry. It's about 50 kilos, so it's able to be transported in a bus or maybe in a van. It's actioned by one person, so anybody, even me, that I'm not that strong, can activate it. And it's supposed to show or simulate a seismic movement in one direction. So when you put the seismic movement on a non-reinforced model, and little by little, small bricks tend to fall apart, which is what happens in real life houses. And it comes one by one, but then later it collapses. So people in that house probably were killed. And we're not trying to scare people, but we're trying to show that attic houses can be fragile. I think I put my best in it, so it's not a quantifier. So I tried to do it as hard as I could. But then, stop. Okay. But then comes the reinforced model. As you can see, we try to use also materials that can be found anywhere to reproduce the small ropes and try to show that the effectiveness of the seismic reinforcement. So now this model is going to be subjected to the same, or at least trying to be subjected to the same amount of seismic movement. We start slow, but even though it's going to move probably as much as the non-reinforced one, the ropes are still going to have the same effect they did on the full-scale model. You almost cannot see the movement because the ropes are going to tie the bricks and are going to preserve the house. But that way is supposed to show also people. That way we're trying to introduce the concept that attic can be reinforced and earthquake resistance. This is going to work side by side with testimonial videos from prior works, from training that was done before in other earthquake scenarios from prior years. Also, another tool we're developing is this construction manual. As you can see, it has friendly illustrations and it has simple numbers, figures, even blueprints, but have to be simple enough for everybody to understand. The common people from Puyo, even though they have no background in construction or engineering, have to be able to read this and build their own houses in a better way. So, taking work from prior owners and improving it, we have made a construction manual, or we are developing it, that has how to select the earth to build your bricks, how to build from the foundation to the roof, where areas to build and where not to. And also, like for this, if you see, there is a woman and there is a child, because it has seen in prior projects that they also contribute to the construction when they're in small villages or communities. Also, that way, it's not only for the men of the house, it's also for everybody to learn how to construct their houses. Finally, later in the project, it's projected that we have to build a social building. So all the community can intervene and can help in the building and in the reinforcement of a social building. For instance, it has been suggested that it should be a school, because that way kids that are the ones who benefit more are going to be, everybody's going to be happy. Their kids are going to benefit from the project. Other buildings may have been the church because they tend to lean a lot on the church. But a community map, which is a psychology tool, is going to decide that on later trips. To wrap things up a little, for us it's important to keep a fluid communication with the people from Puyo. In prior projects has been seen that it's important to get in the mind of the community, to try not just to impose a change or impose something, but to get in their minds, to try to say how they think and keep a fluent communication. If you can see, drawings were made using colors, painting, because we tried to ask the question, what do you want? And people wouldn't say a thing. So in a fun way, let's say we did try to draw what you need, what you want in your town. And they started to be more open. So it has been a continuous work about trying to reach them and try to put a little bit of effort in knowing them. To end this, people from Peru are happy to participate in this project, and we are happy to contribute to their with a little grain of sand to their social sustainability. Thank you for listening to me, and thank you for the opportunity to be here.